Good morning, everyone. Certainly glad to be with you, and I hope you're ready to listen fast. I said I have 20 minutes, so 40 minutes worth of information to be covered in 20 minutes. So what is all this digitalization all really about? If you read a little bit about what I wrote in there, at one point in time, Daniel said to me, give me a synopsis that's 3 or 4 lines. I said, I can't write 3 or 4 lines. So I wrote a little more than that. But everything that fit together yesterday and today is really about this whole thing. So Mark back there led us off and he said, if America is going to take back this industry, what do we have to do? What do we really have to do? We have to talk about digitalization, okay? Or how do we bring all this manufacturing situation back to? And then yesterday, right through 55 about now, so Flint, and I guess this thing's leaving again. Flint Davis said to us, the goal of delivering digital mass customization programs so that manufacturers and brands is really fast and predictable. So how do we do all that? We talked yesterday about all this color, and I learned a ton about color. I didn't know how much I didn't know until yesterday. Now I know how much I don't know. So, are we going to switch?
Yes.
That means you take away from my time, huh? Okay. That's normal.
Sorry about that.
Okay. So, believe it or not, we did all this earlier today, and obviously that didn't work. So, what is this digitalization all really about? So I like what Stefan said when he started off. It's a mixed bag. There's a lot of different things we have to learn. So let's dive into it. So what is this Internet of Things? So all things interconnected, machines and devices and attachments talking to machines. So we can actually look at optimizing productivity and efficiency. How do we do that? With a digital factory automate. So if you look at the upper left, you find a digital machine, and what that digital machine is doing is enable us to connect to a network, if you will, so that we might send instructions to the machine, receive information from the machine, so it might look at maintenance issues, where we might look at productivity and efficiency gains. So what does all that really do? So what are the steps to actually get to that digital factory? So one of them might be to replace your paperwork with a set of instructions. So I'm at the machine and I get these instructions that says I'm going to do this job. Okay? And one of the other things that you might want to do is you might want to collect key matrix from the machine. So the machine's going to tell you some information back. Okay? And so what are some of the other things? So we might substitute the whiteboards that we have in plants for digital dashboards. So we're looking at input and output data and information. And how do we do that? To error-proof our workflows. Stefan talked a little bit about that this morning. Error-proofing what we're doing, making corrective, real-time corrections as you go along. Or we might automate our time stays, because we can actually look at this continuous live data flow back and forth, so we get output for that. And then we might turn these paper-based processes, instructions or worksheets or whatever, into a dynamic app. Again, input, or improve the quality with immediate quality feedback. I believe that's what Stefan was talking about there. So the output, obtaining information back from the machine. To train your personnel with these interactive apps. And do we use these apps to improve our productivity, our quality, our efficiency, and even predictive maintenance, if you will. So we get user-friendly interfaces at the machine level in real time, not batch, because up until now, most of the time we collect all this information during the course of a day, and at the end of the day, we know what we've done, right? Did we correct anything during the day? Not unless somebody ran out there and said, you need to change this now, and this is why. So how do we really do all of this? So in shoes, and some people talked about shoes, you can look at an upper, and most of these shoe manufacturers have addressed these factory of the future scenarios, each one picking some different platforms or whatever. But ultimately, our job in providing equipment is we have to provide equipment and technology so that we can get that information. So it can be done in shoes. Other things, if you look at a t-shirt, so we can automate a bottom hem, or we can automate a sleeve and hem on a t-shirt. We can set the sleeve oftentimes on a t-shirt. So all of those are information, data flow back and forth that we could get by automating these items. And after all, Mark said we have to automate. So how do we do that automation? We do that with things like a pocket hammer that's autonomous. So what we're actually doing here is picking up from a stack pocket material, loading it into a machine, hemming the top of that pocket autonomously. Do you see an operator there? No, can be done without. And then we take that pocket that's been hemmed and we put it into an automatic pocket setter. So we actually load the top of that pocket, if you will. We load the panel then into the machine, and an automatic pocket setter actually sets the pocket onto the panel, okay? Autonomous. There's no sewing operator. In order to do that, we have to have information from the machine. We have to know that it didn't skip stitches, it didn't break thread, the pocket was correct, it was set in the right way, in the right place, at the right time. So what do? We have to have these input devices that Stefan described earlier in order to get that information back from these autonomous cells. Other things that we might look at is in home products. So bed sheets or blankets or fitted sheets or pillow covers, all these different things. So we're actually talking about starting with fabric on one end, processing through, winding up with finished product on the other end. So we're going to make twins and queens and kings and California kings and all these other kind of things, right? How do we know that? It's because this PLC at the front says we're going to produce 10 of these and 20 of these and 30 of these and 50 of these or one. A lot size down to one. Now, Dennis, y'all don't get any problems with that, right? All the time. So a guy says, I want to buy 20 of these, but I need to buy 50 of these also. And so we have to change over. So now we need to automate that process all the time. So home products, we can do some of that with. And then we have robotic integration. So we're integrating here a 6-axis robot into a pillow. Someone said yesterday they produced pillows. So we could actually overlock that, and that's just using an overlock machine to do that particular job. On 3 sides, we're going to come off the back side of that and put a zipper in. Now we could put that zipper in autonomously, or in this case, we're going to put it in one by one. So an operator is going to take that pillow after it's been closed on 3 sides. She's going to put a zipper in it, and it's going to be stuffed, and it's finished. One person. Okay? So robotic integration. Here's other repetitive motion jobs. Somebody said, if it's repetitive, we can do it. So what does an operator do? Day after day. They do one job after another, after another, after another, on and on and on. That's repetitive motion manufacturing. So each of these are indicators of jobs that we can do. Auto drapery hem, the elastic bottom for a band, like on yoga pant or gym pants or something, or 4 sides, like a bath cloth, or your dinner napkin, or the placemat that's on the table. So all different repetitive motion manufacturing. Now years ago, people thought that sewing operators weren't very skilled, right? Wrong. They're very skilled. The dexterity in those hands, the coordination between the hands and the eyes, and so we lost a couple of generations of people. We need to replace that today with automation, right? Yes, that's what you're seeing every day. That's what we're all seeing here in America and across the more developed worlds. Here's other things. So we can actually quilt different products. We can have a rotating head machine to do different products. We can laser cut. We can sew it with the CNC machines. All those are different tools that we use to automate different products. And I'm only running through a few of these. We could talk about lots of different ones of them. Each of these tools we customize. Now, if you don't hear anything else I say today, I want you to hear one thing. One, you don't use the same equipment to produce a t-shirt that you did a pair of jeans, or a shirt, a dress shirt, Oxford, whatever. So it's custom 101 customer-centered solutions. Did you hear what I said? Customer-centered solutions. Not one size fit all. I throw in a bale of fabric up at this end and out the other end spits the product I want, all through the same supply chain. It's not that way. Okay? So other automated sewings like perforation and sewing are programmable CNCs, or machines that we have a robot like the one on the left, the furniture manufacturing robot, to where we actually have Decron fabric on top of it. We're loading it into a machine. That's a materials handling device. That's what a robot is. It handles things, okay, for us. And other hard automation is the same as these robotic automation. Then on the right-hand side, you see one robot actually using an ultrasonic machine on one, and then to cut, and then to seal on the other. So all of these are examples. Or there are things like a laser actually fusing things together. And we have sometimes a preconceived notion that everything has to be done the same way. It does not. You can actually take fabric today and you can mold it just like you've got a ceramic cup or glass or whatever. How? By heating the fabric and it becomes dimensional, okay, and then closing the sides. This is a similar, only we're joining here, whether it's set in, raglan sleeves, or whatever, in order to do this particular job. So technologies that we can utilize to bridge the gap. Here we show synchronized sewing heads. So 2 different heads independently programmed that are actually sewing an airbag. I'm showing a lot of different things because all of us in this room right here produce different type of products. An airbag is one that I need it to be verifiable, don't you? In my car. Well, come to find out, it hadn't been very verifiable before because it was all hand done. And somebody looked at it to see if there was a skip stitch, a broken thread, or whatever else. And then you see these large lawsuits, right? Nobody's ever seen that, right? It even breaks companies, believe me. Synchronized sewing heads. And then we have vision alignment inspection. So here's a t-shirt product that we have to put a logo on. So the system, because of a vision system, is smart enough to know what size, small, medium, large, extra large, and where I'm going to put that logo. Am I putting it in the back or on the front or on the sleeve or whatever? It knows that and it puts it in the right place. Then there's another camera that actually, after the heat set logo is set, that it's looking at it to verify that it is in the right place and that the logo is complete. And then there's vision integration like this, where an irregular shape, like a patch or label, an applique or a number, the pattern is actually done by the camera that looks at it, develops the program, puts it into the machine, and it sews. Then there, like a towel, a kitchen towel, or a microfiber towel, or all of these different items like napkins or others are all automated opportunities. Do any of you see a person in any one of those? I didn't either. That's because there's not one, okay? There has to be someone somewhere that told it what to do, or we make technology to identify what we're doing. So all these are automation opportunities. And then we use material handling devices like these. Looks like this particular one just froze. So I'm going to try to keep talking while I see if I can get it working again. So each of these are tools that we use, and that's tools that we use to implement into our automated process. So which are these tools? Sometimes they're robots, sometimes they're specialized end effectors, sometimes they're hard automation, sometimes they're soft automation, or a combination of all of those in between. Now, hard automation is something like I showed you earlier with a pocket hammer, or the automatic pocket setter that actually loaded the panel and loaded the top patch piece into the machine at the same time. Each of those. Then we have robots that actually load components and pieces. Sometimes we take it from fabric, other times we take it from each individual piece and go into a process or a machine, if you will, to sew your product. Now, let's see if I can get this to pick up from. Okay, here's our robot operating again. Different types of robots. So here are actually 4 different ones. The one on the upper, I better plug it back in. It's running on mine, but not on yours. Now let's see if this works. Well, it did work. Will and I've had a few difficulties this morning. It's working real good on my computer. I could see it. While Will's working on it, I'll tell you a little bit about it. So we utilize, depending on what the application is, it may need to be a single arm robot, like I showed you earlier about a pillar, or a dual arm robot, or a cobot. And what is a cobot? A collaborative robot that actually works alongside of humans. One of the biggest things I think coming in the future is we'll see a lot more of this. Why? We have 2 arms. okay? And then there's vision systems on robotic systems that could actually see like an operator's eye. So what are we doing? We have our eyes and we have our hands, and so we can do the things that operators have. We don't have the same dexterity in robots, but many of these tools can be used. In order for that robot, it has to have an end effector. And what does that end effector do? It handles different things. So if you look at denim, it feels differently than knit, then feels differently than woven, that feels differently than many other, microfiber or other. So we have to use the tools that we have available for that customer-specific application. Remember what I said, customer-centered solution, not one size fits all. Thank you, sir. Let's find out if it runs again. So here are 4 examples of that technology. And the end effectors I talked about. So the upper left is an exohuman hand. So it's a trainable tool, if you will. It's like my hand that actually you train it to do what you want and then it'll pick up. The one on the upper right is sin touch discriminating. So it can tell the difference between knit fabric or denim fabric or any number of different things because it stores it into a computer algorithm, so that when it touches that sensor, it knows what it is. And then needle end effectors we use for a lot of different things. Somebody said, needles? What do you mean? Yeah, you could take a needle and pick up one very thin piece of fabric. You can. And then there are others like the robotic human hand. This is actually a hand that looks like yours and mine that we actually program to do the things we need it to do. And then there's mobile autonomous. So I was at a plant a few weeks back in St. Louis, Missouri. And they have a guy who picks up a card at this end of the plant, and he walks all the way through the plant, and he drops it over here on this end. And then he turns around, he walks back over here to this other end, and he does that all day long. I said to Tim, the plant manager, it's maddening. Doesn't he get bored? And by the way, why do you have him doing that? You could utilize his skill set for something else by using something like this. And there's a lot of different ways. Here's an example of hard automation. So this is a buckle that's loaded. Webbing is inserted into that. It's turned over and it's sewn. So web in, turn and tack. So what are these actually used for? Look at military bags and packs. Or some of you guys that are carrying around bags and packs right now, like this backpack, or car seat, or any number of different things. Jill went to see her grandchild last night. She probably had a little stroller, right? And that stroller had buckles on it, right? Yeah, it sure did. And that's how we do that. So then we have vision inspection. So a camera-based system that actually looks across all of this in a matter of seconds. So this airbag, if you look at it, has a lot of different components, including stitching and others. We can actually verify all that with a camera-based system rather than a human looking at that, which is not verifiable. This is repeatable. So we have to train those vision systems. What do we train them to do? This is good and this is bad. If you can't tell it what's good and what's bad, how are you going to have a camera repeat that? That's what Stefan talked about, repeating. So here's other automation. I like the robotic towel sew. So here's a robotic system. It's a gantry type of system, and what that gantry actually does is we have a little code plate, if you will, like a QR code or could be a barcode or whatever that could say as the system reads it what we're going to sew, and that's the path that it takes. Or we have carbon fiber with a scowl robot. Or we have this dual-arm Yaskawa Motor Man assembling chairs. So I have a customer in Mississippi that manufactures office chairs. He had all this stable of people that sat there and put them together. We took one robot and did the same thing as 8 of them. Okay, and guess what? The next style of chair that comes through, you reprogram it. So I'm not a programmer. Stefan may be. But I can push an iPad, and that's the way you actually store in waypoints for this thing to work. You don't have to be a programmer, in other words. Here's 4 other hard automation projects. One's a parachute line cord. The other one's 2 heads sewing a medical use product. The other web and turn and tack from a single, or the name and rank for a military uniform. All different examples of devices infecting or affecting what a sewing machine does. You're not changing the sewing machine. You're only helping it do what it does. So these are material handling devices, or things that assist us. Same robot on the left-hand side that I just showed you. It was sewing 4-sided on a towel. So in Seymour, Indiana, there's a company that manufactures ironing board covers. And when Tom told me they made $9.5 million a year, I like to fell out of my chair. I said, I didn't know there was $9.5 million ironing board covers in the world, much less in America. My wife doesn't know what one is. I'm wrong, she does. She actually irons quite a lot. But $9.5 million. So he's been exporting all this for years. He got rid of the sewing, sent it abroad to China, India, Bangladesh, Sri Lanka, Vietnam, and all the other places in the world where they had cheaper labor. So we built an automated system, and he can produce ever how many he wants, one at a time, or 1,000, or 9 million. Okay? Ironing board covers. Same gantry robot, different way of handling. Then you see the robot doing the airbag in the upper left. It's like a clamshell arrangement. The one in the lower right, we're actually picking up a zipper tape, putting it onto a zipper fly, stitching it down with a tube needle, then we go back to a J-stitch. So, Mike, we took those two operations and combined them into one, right? We have to do that in many, 30-something operations on a pair of jeans. We think we can do it in 15. We have about half of those done today to actually completely automate a pair of jeans. It's not easy. It's very centered, and it takes time and money. And here are other work cells. So a customer in Houston, Texas called me and said, I make boas. I said, excuse me, I don't know what a boa is. You ladies knew. I didn't know. I had no idea. He said, oh, this is flowery thing or flirty thing that goes around your neck or whatever. I said, oh, that's great. I'd never seen one of those. And I bet Andy Arkin never wore one, nor had I. So he sends me one of these things. Why? He can't get people. So we make an automated system so he can take a one-eyed monkey and he can load this thing and sew the products he has. We have others that are in the glove industry. So it's a 3D knitted glove, and then we have to close the top knit wrist. So we do that with a dual head cylinder arm type machines that has an edge guidance system to load and unload the products. It takes a person. Now we can do that with a machine, but they didn't want to spend the money. I think, Stephan, you said something about that. They may not want to spend the money. So we automate as far as we can. And then we have to use devices. So a lock stitch machine has a bobbin and bobbin case. Why? The nature of a 301 lock stitch means that the thread has to go around the hook, pulled up, and actually forms a knot, which is a lock stitch. In order to utilize that machine with automation, somebody had to change the bobbin and bobbin case. Now we can do it with a device. Or a skip stitch detector. Or a device that actually has a probe that goes up into the bobbin and bobbin case to see if there's thread. So all devices that we use to automate and integrate robotics and automation. So the automated strap. So ladies who wear a swimsuit or a bra, each of those have a strap, automated strap set up. So takes the strap, ultrasonically seals the strap, takes the metal, forms the metal, actually coats the metal, inserts it into the D-ring, and makes the strap autonomously. Or the machine on the right, upper corner, XY Theta turning head machine, all scalable. This one right here is about a 600 by 600. We have a machine in West Virginia that sews 7.5 meters long this way, turns around and sews 7.5 meters back this way, 1/8 of an inch apart. It's a de-icing boot for an airplane wing. We also have machines like that undersew. Underneath tile, oftentimes you have a heated strip, a wire, if you will, that goes around. We do that with a machine like this. It's programmable, CNC, that we can program to do that job. So we use them for a lot of different things. The other two are hard automation to do driver's side airbag or the collar or cuff. Three-dimensional sewing. So one of the hardest things in the world is three-dimensional sewing. We're joining things that aren't flat. If you look at most products, about 70 to 75%, sometimes 80% of the products are components. So that shirt that you may be wearing is about 75% components. And then there's a final assembly. The final assembly is the hard part. We can automate the majority of the 70 to 75% as components, as parts, and then feed a final assembly. So we could take a plant that's got 250 or 300 people in it and actually operate it with about 25 or 30 because we can automate those 70 to 75% and we could use the final assembly 25% or so with people. Okay? These are only examples of three-dimensional. Okay? The shoe. So in a shoe, the toe, the heel, the bottom of the sole are all dimensional. The rest of it is flat. A dash panel, the machine is actually picked up and goes up and down like this. How do we actually do that? We take a laser and we shoot a beam across there, and then as we're sewing it, we have another one that actually feeds back that adjusts the machine. Because as I sew thick goods, it varies, it moves. It shrinks or contracts, so I might have to adjust that. All technologies that exist today. So I thank you for your attention this morning. You're fast learners. I could tell you listened really fast, and I'll ask you any question that you might have. I'll let Jill answer it right over here.